Okay, this question says find the interval of convergence using interval notation and fractions rather than decimals in the function of x represented by this geometric series. Okay, so this is a geometric power series. It's a power series because there's an x involved. Let's just write out the first. Let's write out the first few terms here. So when n is a 0, notice I get a 1, right? Because I get negative 1/2 to the 0, so I get a 1. Okay, and and when n is a 1, I get negative 1/2 x minus 3. Okay, and when n is a 2, I get negative 1/2 squared, but that's positive 1/4. I can change that later. Okay, so far so good. So it is a geometric, which means there's a common ratio. This is I guess I call this my 0th term. This is my my first term, my second term. If you want the common ratio, no matter what you're looking at in a geometric, you can always take any term and divide it by the one before it. So if I take the first term and divide it by the 0th term, for example, I mean, you may see this at a glance, but if you don't, in a certain case, just always take any term and divide by the one before it. So that tells us that our common ratio is negative 1/2 x minus 3. And then again, this is fitting the form, every geometric in general has this basic structure. Okay, and we know that's equal to, okay, so we're going to get our function from this expression. Okay, so I have, I have my first term is a 1. So it's going to be 1 over 1 minus the common ratio, which again we just figured out here. Okay, so we'll clean it up in a second to write it nicer. Okay, so that'll be the function. That's what we're going to put here, whatever this kind of cleans up to be. And then we'll do the interval of convergence in a second. But let's clean this up and zoom on this and clean it up a little bit. So you would write, to really make it look better, you write it 1 plus 1/2 x minus 3. And then it's a little awkward to keep, there's better ways of representing this. Not that anyone's more correct than the other, but if you times by 2 on the top and the bottom, the top becomes a 2, or 2 over 2. The top becomes a 2. When you distribute this 2, you get 2 plus, and then 2 times 1/2 is 1. So you get 2 over, and then this 2 plus this negative 3 gives us a negative 1. So we get an x minus 1. So 2 over x minus 1 is the function. And then the interval of convergence we inherit from here. Okay, so our R value here, right? We're just going to use the this criteria. Okay, so for us, we need that. Okay, which means we say this. Okay, multiplying everything through by negative 2 to kind of clear that negative 1/2. Okay, so then this becomes a 2. Now I multiply by a negative, so I'd have to switch the location of the direction of the inequalities. Okay. And then add 3 to everything. Okay, which is probably more recognizable, which in interval notation we write like this. Okay,